Hello friends, today we'll discuss about what are the benefits of MapReduce, benefits of Spark over MapReduce. So I have created few videos regarding this as well. So the very first benefit is its speed. So the performance of Spark is good as compared to MapReduce because of its in-memory processing. Okay, so Hadoop can do only disk processing. What does it mean? It Hadoop can store, I can say MapReduce store its intermediate data on the disk, but Spark can store the intermediate data on disk and in memory as well. So if Spark store its intermediate data in disk, then it is 10 times faster than MapReduce. And if Spark store is intermediate data into memory, then it is 100 times faster than the MapReduce. And another thing is MapReduce is able to do only map and reduce kind of processing. But Spark can do different kind of processing as well. You can do MapReduce kind of things in Spark as well, but other than that, you can do join, group, and you can do join, group, and different kind of processing. Okay, and in MapReduce can only process data into form of batch processing. What does it mean? The batch processing data is somewhere stored on the HDFS, and MapReduce can process the data in the form of batches. Let's say you have a data of 1,000 rows, and MapReduce can divide the data into 10 batches of 100 rows each, right? But Spark can do streaming processing. What does it mean? Spacing processing. It can read data in a stream basis. It can read data in batch processing as well. It can do machine learning. Interactive SQL query can be written in Spark. Okay, and Hadoop is highly disk dependent, but Spark is not. It is all Spark can use memory as well. Now, this is the example of one MapReduce job. So I can say the multiple map reduce job as well. So if you say in this iteration one, I have three map reduce tasks which are reading the data from the disk. Now there should be some output from these tasks. Then out those this output will be written on a distributed memory. I can say on a disk. In iteration 2, again, for the next job, few MapReduce tasks are reading the data from distributed system, and again they are writing this data into a distributed system and all. Now, this is a combination of multiple MapReduce where multiple jobs are reading data from somewhere and writing data to somewhere. Let's say if I did the same thing with the help of Spark, then this intermediate data can be in, written into the memory, task memory. I can say RAM, not on the disk. But Hadoop does not provide this facility. Now, this is the component diagram of Spark. So, what is the component diagram? Here you can see I have a driver program. Okay, then I have few worker nodes and cluster manager. So let's start from the cluster manager. So what is the cluster manager? Cluster manager means like yarn. Let's say you have a Hadoop cluster of two nodes, two data nodes. Okay. So these are the data nodes and this is the yarn resource manager. I can say that this is the yarn. These three are representing the yarn cluster, right? Now I want to do some processing on this yarn cluster. Data is already there on this two node cluster, and I want to do some processing with the help of Spark. Then I need to run Spark somewhere. I need to start Spark somewhere, right? So if I say these all in Spark terms, so the data nodes, yeah, I can say node manager in yarn is called the worker nodes in Spark. Okay, and worker nodes are those nodes where data is reside, and these nodes will be used for data processing by the different Spark task. Now what is the driver program? Driver program is where you start your Spark application, from where you launch your Spark application. So in another words, I can say where you create your Spark context. So this is the main program from where you start your processing. So in this example, I am reading a text file with the help of a Spark context. So what is the Spark context? Spark context mean it is the main entry point into your Spark application. So I am reading a file with the help of a Spark context into multiple lines, and I'm filtering those lines with the help of word 1. Let's say I want only those lines in which word 1 present, and return the very first line in which word 1 present. So this is my code I want to run. Yeah, I can say this is my analytics. So now the main method in which I'm writing this program is called the driver program. And in the driver program you have the Spark context, right? So when you write this program and you launch this program, so what does it mean? First, this program will be divided into multiple tasks. Okay, I can say multiple jobs and multiple tasks. Okay, in another word, I can say this program will be divided into multiple jobs, and each job will divide into multiple stages, and stages divided into multiple tasks. So what is the meaning of stages? Similar tasks can be executed in a similar stage. So now, before that, Spark scheduler divide this program into multiple tasks. Means how many tasks will be required to do this kind of processing, and ask the cluster manager to allocate the resources for these many tasks. Okay, then Yarn cluster manager, which is Yarn, so Yarn resource manager allocate the resources for his task. So now allocated resources called the executor. Okay, so in simple words, I can say Spark scheduler divides this program into multiple executors. If I say so, Yarn allocates multiple executor for these for this application. Now, what is the executor? So Yarn allocates, I can say resource manager allocate multiple executor on multiple worker nodes where data reside. Because what I'm doing, I'm creating an RDD over this file. So the data, so the node on which this file, so the node on which the data belongs to this file will be used as the worker nodes, and executor will be running on only those node, only on those nodes, right? So worker node will be allocated, and each worker node multiple executor will be allocated, and each executor can execute multiple tasks. So this is the different. So what is the executor? So executor is used to execute multiple tasks, and one executor takes one container. Okay. So in Yarn, in Spark, you can say your executor is taking one container, and in one container you can execute multiple tasks. But in MapReduce, one task take the one container. So Spark supports the resource management as well, right? So now, let's say two executors are allocated and they are executing total 4 tasks, right? Now, during the execution of this program, till this application gets completed, Spark context communicate to these worker nodes. Then communication is happen, means communication is continuing, right? Now, this communication will be terminated when this application gets terminated. Okay. Now, this is the architecture of Yarn. So if you see that in Resource Manager, two clients are launching their application, and for each application, one application master is allocated. So in our case, two application master are allocated, one application master for client blue client, one application master for this pink client. Okay, now this application master is used to allocates the used to allocate the multiple resources, and to what I say, to monitor this application. So now